With that, we'll quickly move on now to the SODA Incubator projects update. SODA Incubator provides services to projects associated with data and storage to help them develop, grow, and be adopted by SODA end users and the larger open source community. It helps projects join the SODA ecosystem, adopt the SODA governance, and guides them to services available with SODA Foundation. It gives me great pleasure to introduce you to the first of the SODA Incubator projects, the DAOS and the YIG project. Here to speak about DAOS is Zheng Liang of Intel. We will be having the talk from YIG by Sun Fangchen from China Unicom after that. So over to you, Zheng, for DAOS.
Okay, yeah, let me try to share.
A note, I will be sending across time checks in your chat, so please keep track of your chat.
Yeah, sure. Can you see my screen now?
Not yet, please. Yes, we can see it now. Thank you.
Okay. Hi everyone, my name is Liang, and I'm the tech lead of the DAOS team of Intel. And today I'm going to present DAOS, which stands for Distributed Asynchronous Object Storage, and introduce the reason that DAOS joins SODA Foundation. Originally, development of a distributed file system was driven by checkpoint restart use case. But today, a new type of storage workloads from big data and AI are emerging. For example, different stages within AI data pipelines have distinct storage requirements. So it could submit massive writes in initial stage, then need mixed and read and write handling, and then significant amount of random reads in the final stage. So these workloads are quite different while comparing with the checkpoint restart workload, which is mostly streaming I/O. So our goal is really building the storage system can support all these workloads. We started to look into technologies based on new hardwares like persistent memory and NVMe SSDs. So those user space library to support these devices like PMDK, SPDK. So this page presents the architecture of DAOS storage on the right side, and a more conventional storage system on the left side. And as you can see, parallel file systems are built from the ground up with the disk drive and use kernel space block interface, which is optimized for disk drive. But it also means that each I/O has going calling to the kernel space. And on the right side, it is the new storage architecture of DAOS. It's built from the ground up with the non-volatile memory. It totally bypasses all the Linux kernel I/O. It does not do any system call during I/O on both client and server. So it's an end-to-end user space storage system, and it's built over 3 building blocks. The first one is persistent memory and a PMDK. So DAOS use it to store all the internal metadata, application metadata, and latency sensitive I/O, which means that all metadata and low latency I/O go through the I/O channel and use memory interface load and store to access persistent memory. And the second building block includes the NVMe SSD and the SPDK. This is really for capacity and large streaming I/O, and here we don't actually use any traditional kernel I/O interface. Instead, we use the SPDK, which provides the user space NVMe driver, so we can submit I/O directly from user space without switching into the kernel. The third building block is the network side. Currently, we're using LibFabric. It can give us very low latency communication and very scalable collective communication over Fabric, and support RDMA from user space. This page, let's look into the DAOS stack. DAOS is a large capacity tier, right? And it manages its own metadata, which means that we don't need the third-party file system in the back to maintain all the POSIX namespace and the metadata. So it's a standalone tier, and as presented in the diagram, in order to provide very low latency I/O, DAOS client is just a library which is integrated with the application, and run in the same address space as the application, and the data model exposed by the DAOS library is directly integrated with all the traditional data format and the middleware libraries. And we will discuss this later. So on the server side, the DAOS server runs either on the data storage node or container. So it can directly access PMEM and NVMe SSD from user space, and as introduced in previous page. So it stores metadata and a small I/O in persistent memory and large I/O in SSD. So it is a storage system that is end-to-end in user space. This page, I'll shortly introduce main features of DAOS. First of all, the DAOS control plane, it is responsible for initial configuration and optional management of the DAOS service. So the control plane provides interfaces for an administrator to configure and start a DAOS cluster. And the control plane service and the tools manage the running cluster and provides optional status and collect telemetry data. I won't be able to go through all the core features listed at here, but I will take a minute to introduce the data protection and self-healing of DAOS. Because DAOS is a storage system, can deploy it on storage cluster with thousands of storage nodes. So failure is not a rare event in a large deployment, and DAOS should be able to prevent data loss by software data protection. And it also should be able to respond to I/O instead of blocking when failure happens. So DAOS provides both replication and erasure code for data protection and recovery. Both of them can protect user data by making use of data redundancy. And the eventual goal of having the data protection is system resilience. So user data can be recovered to the same redundancy level and tolerate the same number of failure. So with support of data protection, DAOS has a self-healing system. It's a background service that can automatically detect a failure and reconstruct the data redundancy when failure happens. So yeah, there are many features, but we don't have time to go through them. This page is DAOS API. We are providing a new data model, which is pretty much like it's an object store with KV, I mean key value API, but the value can either be a regular KV API, I mean it's a whole thing, it's a whole piece of data, or can be array value, which means that user can overwrite arbitrary can write from arbitrary offsite and do overwrite. So yeah, anyway, the new API provided by DAOS storage system is the red box at here, and we are working on different middlewares and data formats to integrate DAOS API directly with them, so we can avoid all the POSIX serialization constraint. So currently, we have DAOS HDF5 plugin, we have MPIO driver, and we have the direct integration of libDFS with Apache Spark, and we are also working on extending the ecosystem. Like for example, POSIX.io is supported through the one of our client library libDFS, and Apache Arrow is a new data format for big data. It can be natively represented on top of DAOS API, and TensorFlow and NumSQL are also in our list of IO middlewares. For example, we can implement a Python module for TensorFlow, so you can load data set stored in DAOS container, or use DAOS as a storage engine for NumSQL database. So anyway, DAOS can provide a lot of advanced feature of storage engine, like high performance data consistency, scalability for storage. So it can be easily integrated into different IO middlewares. And we also want to integrate with any existing storage tier, so user can deploy DAOS smoothly and integrate it with any existing capacity tier like Lustre, S3, and HSM. We are providing data mover, which will be available soon, and at that point we will be providing a parallel data movement capability at the POSIX level, but also all those middlewares which will be yeah, and for all those middlewares which will be directly integrated with the DAOS API. So yeah, be part of Soda Foundation. First of all, we think DAOS can match with all the prerequisites of Soda, and it's an open source distributed storage system, and it provides it's an object store and provide key value interface. It can provide it can already provide plugin for different IO middlewares, and we are working with other partners to support more middlewares. And the building block that DAOS depends on, they're all vendor neutral. PMDK is a senior standard, and the SBDK is a vendor neutral, and LibFabric can support many different network providers. So, and DAOS is also a leading technology. I mean, DAOS is a storage system that's based on new storage hardware and can support data pipelines for different applications like traditional modeling, simulation, high performance data analysis, and it can also power AI pipeline by providing ultra low latency random IO and providing massive ingest bandwidth. So we want to join Soda to increase our influence in the industry, and it can be a candidate solution for users that want to use the persistent memory or NVMe storage, and we want to understand more about the business requirement from and the use cases from different users to improve the product, and we definitely want to be part of the data standard. And the last page is really just a roadmap. It's a roadmap, community roadmap, and currently we are working on the 1.2 release. And as you can see here, many main features will be either be ready or have a preview version in this release. And for the next year will have the 2.0 version, which will be deployed in Argonne National Lab and in the Aurora system. So it's a super large storage system. Okay, I guess I'm running out of time, and that's all the slides I have.
Thank you so much, Ringliang. That was really nice, and welcome to the Soda Foundation family. We are very glad that you have decided to incubate here. With that, very quickly now, let's move on to the next session, and that is going to be by Sun Fangchen, and he's going to be talking about the YIG project from China Unicom. Over to you, Sun Fangchen.
Okay. I'll share the slide.
Yeah. Yes, we can see your slide.
Can you say it?
Yes, please.
Okay. Hello, everyone. My name is Sun Fangchen.
Can you present, because right now we are seeing your slides but not the presentation view.
Oh, wait a minute.
Yeah, if you're presenting, then kindly share the presenting screen and not the. Yeah, we can see it now. Thank you.
Oh. Hello, everyone. My name is Sun Fangchen, and I am a senior software engineer of China Unicom Cloud Data Company. Today, the topic I share with you is YIG S3 storage performance tuning. First of all, let's introduce YIG. YIG is the abbreviation of yet another index gateway. YIG is a completely new designed object storage gateway framework that is fully compatible with S3 at its core. YIG is turned mini-O backend storage to allow more than one subcluster work together and form a super large storage resource pool. Users could easily enlarge the pool's capacity to EB level by adding a new subcluster to this pool. Benefits are avoiding data movement and I/O drop-down caused by adding new host or disk to older subcluster as the usual way. To accomplish this goal, YIG needs a distributed database to store metadata information. 一个 first 一个 introduction. The top is 一个 gateway instance, which is stateless. It can dynamically expand the number of the instances according to the business requirements. Under the 一个 instance, it is a cache layer for data and metadata. On the left is the IAM module, which processes the authentication information in the request. The metadata module on the right can use TIDB or HBase to save metadata. The box in the middle represent multiple self-clusters. At present, Eagle uses self-cluster to save data, which can expand the self-cluster to use storage backend online. Second, Eagle features. Eagle can use different storage backend. Eagle can use different storage backend to store objects. Ceph is not the only backend for Eagle, and we abstracted the I/O interface for reading and writing data, which can interface with other storage backend. Eagle can use different metadata storage, and Eagle also abstracted the interface to access metadata, which can connect different metadata storage clusters. Eagle can store objects at different backends depending on the size of the file. Eagle can avoid data movement and I/O dropdown caused by the scaling of the subcluster. Eagle uses the unified cache to cache metadata. Second, profiling YIG. YIG is implemented by Golang language. Golang has a package called pprof that provides a HTTP server with runtime profiling data in the format expected by visualization tool. We find bottlenecks by Golang profiling in YIG and optimize the process of the data and memory utilization and reduce the pressure of GC. Third, replace the TIDB with TIKV. TIDB server. This is TIDB architecture. TIDB server. Let's take the TIDB architecture. From the figure, we can see that the TIDB platform is comprised of three key components: the TIDB server, the PD server, and the TIKV server. The TIDB server is in charge of following operations: receiving the SQL request, processing the SQL-related logic, locating the TIKV address. It does not store data, and it is computing only. Placement driver server. The placement driver server is the managing component of the entire cluster, storing the metadata of the cluster, locating the transaction ID that is globally unique. TIKV server is responsible for storing data from an external view. TIKV is a distributed transaction key-value storage engine. We initially created several tables, buckets, objects, multiple, and other tables on TIDB to store metadata information for S3. Now we no longer need a TIDB server. We can communicate directly with the PD server and the TIKV server through Collect API, which significantly improves the performance. Fourth, add data cache tag. Some of our customers are video monitoring customers. They these customers have high requirements on write performance, especially sensitive to write latency, and have greater demand on complexity and low requirement on read performance due to the consideration of the cost. Only HDD disk can be used to store data. We think of adding a layer of cache tier in YIG. The data is first written to the cycle pool composed of faster SSD, and then the data is migrated to the cluster of HDD disk in the background. When reading data, objects are read from SSD pool or HDD pool. Fifth, add local cache for object reading. Some of our customers developed file sharing about YIG, and the same object will be downloaded by multiple clients at the same time. So we developed the read cache function in YIG. We add a LRU linked list when each file is read. The information describing the file will be put in the head of the list, and the number of the file access will be accumulated. When the number of access times reaches a certain value, the file will be written to the local file system as a cache file. The cache information of the file that has not been accessed at the specified time will be cleared from the LRU linked list. In addition, if there are cache files, they will be deleted together. After the implementation of this function, the performance of file reading has been significantly improved, and the reading pressure of storage backend is relieved.
So function, I have to interrupt here. We are out of time, so I would request you to make your closing statements, please.
I have your pardon?
We are out of time. You have almost reached the end of time, so I would request you to make your closing statements if you can, because we are completely out of time.
Okay. Fifth, replace LIBRADOSSTRIPER. Objects are written in YIG self-cluster using the library of self. Both the write and read of LIBRADOSSTRIPER API will lock the object. We encountered a self failure due to the wrong locking mode of LIBRADOSSTRIPER after the bug appeared. On the one hand, we submitted a patch to the self community. On the other hand, we decided to use the most basic I/O liberados to implement the I/O in the strip mode. We save the strip information in YIG's metadata. The objects written to YIG self backend will no longer be modified and only be deleted in the future. Therefore, there is no need to lock the object, and it simplifies the process logic and improves the read-write performance. Okay, that's all from my side. Thanks.
Okay. Thank you, Sung Function, and welcome to SODA Foundation. Thank you for your contribution to the SODA Foundation projects. We are very glad that you decided to incubate with us.